Hi there, I'm Peter, Managing Director of GlasCurtain. We're a Canadian manufacturer of fiberglass-framed curtain wall systems for triple-glazed applications. And today, we're going to talk about thermal charts. So, thermal charts. How do we read these things? I'm sure many of you have come across thermal charts before, but every thermal chart is a little bit different. They can have different x-axes. They can have different y-axes. They have 19,000 different kinds of lines on them, and what do they all mean? So when we're looking at different thermal charts, we might be wondering, how can we get an apples to apples comparison? Well, for that, we want to keep our x and our y-axes consistent. So here, for our x-axis, we have vision area over total area. And then on the y-axis, we have overall system U-value, with a whole bunch of different lines relating to different glass performances. This is the standard chart that we use in GlasCurtain, but let's break down how this chart really works. But before we get too lost in the nuts and bolts, let's zoom out a little bit and take a look at U-value in the context of system performance. So when architects and specifiers are looking at whole curtain wall system performance, there are a lot of factors to consider. There's acoustic performance, there's condensation, there's air and water, and of course there's thermal performance. Thermal performance, even in that category, comprises a whole bunch of different things, including solar heat gain, visible light, shading, and then of course the primary subject of today's conversation with thermal charts, U-values. So what is U-value from a physics perspective? Well, it's really a measurement of the rate of energy flow from an area of warmer temperature to an area of colder temperature. And this is obviously exacerbated more so in cold climates, because it's much easier, much more plausible to have a 50-degree difference between interior and exterior environments in a cold climate than it is in a hot environment. If we're trying to maintain, say, 20 degrees Celsius on the inside, there aren't a lot of places in the world where it's 70 degrees above zero, but there are definitely a lot more places in the world where it's minus 30 or even minus 20, as we have here in northern Alberta with the Métis Crossing project that we did. And so, as we can see here, these arrows are sort of indicating, exactly how much energy is flowing between the inside and outside environments, and the lower the U-value, the less energy will move between those two environments. So if we want, 0.1 watt per meter squared Kelvin walls, so that's U-value from a physics perspective. But what's U-value from a system perspective when we're talking about curtain wall? Well, it's specifically the frames, the glass, and then also actually the edge of the glass. So that's kind of it. That's what a curtain wall is. A curtain wall is framing, stick-built framing in the case of GlasCurtain systems, glazing, triple glazing in the case of GlasCurtain systems, and the edge effects that impact the system performance. But once we have that value, we can plug that right into our models. So how do we actually do the calculation? Not that you'll ever need to, thankfully, but this is basically the formula. And you can see here that we have the sum of the U-value of the frame times the area of the frame plus the sum of the U-value of the edge of the glass. It's amazing actually how conductive the edge of the glass can be. Times the area of the edge of the glass plus the U-value of the glass itself, the vision area, times the area of the glass itself divided by the total area. And out pops the U-value of the total system. So how do we find some of these values to plug into the equations? Well, thankfully, manufacturers provide these for us. So when we're looking at different glass makeups, for example, we can find the center of glass values, we can find the edge glass values, and you can call us, we can give you the frame values. So here's an example of some of the center of glass formulas, and you can play around with the different lights, different spaces, whether you have argon or one kind of low-E coating or another kind of low-E coating. So there's obviously very many variables with glass, and you can play with all of these, and out pops these from the LBNL window therm program, and that's how we find the values here. Now let's see a visual example of how this all comes together. With a curtain wall in particular, we actually only use half of the frame width on any given side. If we were doing a window wall or any kind of like retail storefront or something, we'd actually use the full width at the sill and at the head. But with a curtain wall system, because we're imagining that it's actually extending out in every direction beyond the standard NFRC 2 meter by 2 meter size, we're actually only using half of the width here which with the GlasCurtain system is 63.5 millimeters wide. And then we do have the full width mullion, and then just in the middle, and then the glass area in between. And yeah, standard is 2 meters by 2 meters. And then we just put in all our values and voila. And then once we have all the data, now it's time to visualize it. And there are, broadly speaking, two ways to visualize the data. There's the kind of chart that we typically use, the GlasCurtain, on the left, where we're using an x-axis of vision area divided by total area. And there's the kind seen on the right, which has a center of glass U value. But this is the challenge of this system, or the limitation of this system, is that they're really one per frame size. You sort of have one chart per frame size. So this is based on standard reference 2 meter by 2 meter or 2000 millimeter by 2000 millimeter. Whereas the chart that GlasCurtain typically uses is more accommodating, more flexible for different kinds of frame sizes, since basically every curtain wall is a different size. The chart on the right, you would need a different chart for every different frame size. So if you have 1.5 meter by 3.5 meter, or 1.5 or 2 meter by 4 meter, you need a different chart for every one of those. Whereas here, with this vision area divided by total area, which we'll get into in just a sec, we have a lot more flexibility and adaptability in reading all these different lines, which each one corresponds to a different center of glass U value, which are all the common center of glass U values that we offer in our systems. And then you can sort of just follow along the lines and see where the overall system U value will be. So for example, we would take, vision area divided by total area of 0.92, go across, and we'd end up with, say, 0.76 overall U value on that light blue line. But let's figure out what this vision area and total area numbers mean and how we can apply them. So let's start with total area, which is just going to be the total area of our curtain wall. The trick being, of course, that we only calculate to the middle of the frames on the outside, so along this dotted line. That will be our overall frame. But most projects are different. Pretty standard is sort of 1.5 meter between the verticals on center, and 3.5 meters height. And then we have our vision area, which is pretty self-explanatory, but here we have to not forget the edge glass area as well. So we have basically the whole glass area between the two sets of mullions. If there is an intermediate mullion there, then we would calculate that full edge of glass area plus center of glass area to get our vision area. And then we divide those two numbers, and voila, we have our x-axis for our thermal chart. So now we get to put it all together. Here we have, let's say, vision area of total area of 0.92. Pretty reasonable. And let's say we have a center of glass value, which we have a chart here. If we have, triple OE coating, triple glazed IGU, that'll usually be in the 0.6 watt per meter squared Kelvin range. That's this light blue line here. If we have double OE coating, let's say 2 solar band 70 XLs, we'll be in the range of 0.67. If we have 2 solar band 60s, it'll be 0.70. And if we have just a 1 solar band 60, it'll be in the range of 1.02 watts per meter squared Kelvin for the IGU. But let's say we have good glass, the good stuff. So triple OE. That'll be the light blue line. That's our line kind of in the middle, towards the middle here. We have a vision area of 0.92, crossing over, voila, 0.96, or 0.76, excuse me, even better, 0.76 watts per meter squared Kelvin, overall system U value. That's pretty exceptional. That is pretty much the best curtain wall in the world for thermal performance. Our standard GlasCurtain systems will, being in the range with a triple glazed, triple OE glass, will be in the range of 0.76 at vision divided by total area of 0.92. But what happens if we use even better glass? Because there is even better glass tech out there. What happens if we use vacuum insulated glass? We're using vacuum insulated glass on a new project actually in Edmonton, upcoming, and it's going to be 34 millimeters overall thickness with a center of glass value of 0.4 or 0.39 watts per meter squared Kelvin, which is this yellow line here. And the sizes of these pieces of glass is only increasing. So that's why we have this dotted line over here as that manufacturing technology improves. And we can see that we would get down to, with that 0.92 vision area of 0.66 watts per meter squared Kelvin. So about 0.1 better, which is like more than one R value point basically. So a huge bump up just from improving the glass. And then of course we have our passive house system as well. And our passive house system is our new framing system with reinforced nosing area essentially with higher thermal performance in that sort of critical section of thermal bridging. And we can actually see how flat this line is to show how insulating that frame is. The worse insulating the frame, the steeper these lines are going to be. The better the insulating the frame, the flatter these lines are going to be. And that's sort of how we read a thermal chart. And of course, if you need a little bit of a cheat sheet, we're happy to help with different frame sizes. Of course, the advantage of this kind of chart is that it's so legible for different frame sizes. And you know, bigger glass is definitely in vogue. I mean, who doesn't want more views? Who doesn't want more of a connection to the outside world? As you know, those of you who've seen our some of our previous videos, we talk about this a lot. You know, about whether it's passive house projects or LEED projects or net zero projects. The whole idea of having high performance windows is to maximize daylight and a connection to nature. So, quick little hack here. You know, some of the pieces of glass that we have here at 0.91, 0.92, 0.93, 0.94 are 2 meters by 2 meters, 2.5 meters by 2 meters, 3.25 meters by 2 meters, and 3.25 meters by 3 meters. So those are very large pieces of glass. So what we're seeing is that still the thermal performance just gets better and better. So the larger the piece of glass, yes, the heavier it is, and you know, there's definitely sort of cost implications of that kind of thing as well. But we do see that the thermal performance of the overall system improves. But we're actually penalized a lot less in a fiberglass system relative to aluminum frame systems for using smaller glazings. So for certain design aesthetics that are using smaller glazings, there's much less penalty for using a fiberglass framing system compared to an aluminum frame system. So these lines in general are very flat, and yeah, we can accommodate all different sizes. So there you have it. That's how we read those sometimes tricky thermal charts. Since every thermal chart is a little bit different, every manufacturer sort of uses one sort of presumptions or another set of presumptions, one set of axes or another set of axes. Hopefully we've sort of demystified some of how these work, and they can be pretty fun. And of course, if you ever have any questions, feel free to reach out to us. Our email and links will be in the description below. You can also follow us along on social media. We're on Facebook and Twitter and LinkedIn and Instagram, right? Don't forget Instagram. And of course, we also publish a semi-regular newsletter as well every month or two, and we'll also put the subscription link to that in the description below. That's all for now. Thanks very much. We'll see you next time.